All right. So our last two guys are examples of double replacement reactions. The first one, E, goes like this. A solution of silver nitrate and a solution of calcium chloride are mixed. Silver chloride precipitate forms. So, if I look at my reactants, my reactants are silver nitrate and calcium chloride. And if I look at my products are well, I'm only told silver chloride. I'm kind of left hanging about my second product. But this is a double replacement reaction caused by mixing two ionic compounds. So I should just look to see. I've covered the silver on both sides. I've covered the chloride on both sides. What's left are calcium and nitrate. So if I'm doing a double replacement reaction, a change of partners, then the only possibility here is calcium nitrate. So that I cover the calcium and the nitrate that were here and here. So this is a double replacement reaction. And all the ions I started with switched partners to different partners by the time I was done. Okay. Now, silver has a charge of +1, and nitrate is a complex ion, NO3 minus, with a charge of -1. So altogether, my chemical formula there is AgNO3. Calcium is Ca with a 2+ charge, and Cl with a 1- charge. So altogether there, my chemical formula is CaCl2. Once again, silver is Ag+, and chloride is Cl-. So I get AgCl. And then calcium is Ca2+, nitrate is NO3-. So I get Ca with 2 nitrates, NO3 in brackets, 2. So I've fully identified all of my products and all of my reactants, and now I can go ahead and write the balanced reaction. I have AgNO3 plus CaCl2, giving me AgCl and CaNO3, 2. My balance here is not too bad. I just double up here and double up here, and then I get 2 silver on both sides, 2 chlorine on both sides, 1 calcium on both sides, and 2 nitrate on both sides. So that all works out. One last note I can make is that I have this stuff dissolved in water, AQ, this stuff dissolved in water, AQ. This was my precipitate, it became solid, while this stuff stayed dissolved in the water. Alrighty. And then our final F is another double replacement reaction. This one says a solution of barium chloride and a solution of lithium sulfate are mixed. Barium sulfate precipitate forms. So we're doing the exact same process as last. We're listing our reactants, which in this case are barium chloride, and lithium sulfate. And we're taking a look at our products, and we're only actually told one of the 2 products. We are told that we get barium sulfate, but since this is a double replacement reaction, a reaction that involves 2 ionic compounds, 2 salts, trading partners, we can easily figure out that, okay, we took care of the barium, we took care of the sulfate, so we must have lithium chloride as our other product. Cool. Then, barium has a charge of 2+. Chlorine has a charge of 1-. Overall, barium chloride is BaCl2. Lithium sulfate. Lithium has a charge of 1+. Sulfate is a complex ion, SO4 2-. Overall, I get Li2SO4. Then over here, barium has a charge of 2+. Sulfate has a charge of 2-. Those are instantly balanced against each other. So I just have BaSO4. Nice, no brackets. And then finally, lithium chloride. Lithium has a charge of 1+, chloride of 1-. Those are balanced, so I get LiCl. Whew. Okay, so having identified all of my reactants and all of my products, we can now go ahead and write that BaCl2 plus Li2SO4 forms BaSO4 and LiCl. Then I can balance with the 2 here. If I note that this was dissolved in water, this was dissolved in water, this became a solid, and this stayed dissolved in water, then I can read off my description and it makes perfect sense. It says a solution of barium chloride is mixed with a solution of lithium sulfate, and a solid precipitate of barium sulfate forms, which means that unmentioned lithium chloride stays back. Okay, so hopefully those are feeling a little bit better. We will continue to practice in class tomorrow. I'll see you then.